Hi everyone. Today we are going to be writing rational equations from graphs. So in this set of notes, we're going to use the graphs that are given to write the formula for each of the following rational functions. So we're provided a rational function, and then in order to write the actual function, so f of x equals something over something, okay, we know it'll have a numerator and a denominator because it's a rational function, it's a hyperbola. But in order to do that, I need to fill in all the missing pieces. And with a graph, it should be relatively easy to do that. Now, I noticed that on my graph, it's kind of counting by twos. So I might want to go in and fill in the odd numbers. So like 1, 3, 5, 7, and so on. -1, -3, -5. Just helpful to fill in those pieces so that we can see exactly what's happening. Now the X-Intercept is the ordered pair with an X value and 0 for its Y. So I go look along the X-axis and the graph crosses right there at -2. So there's my X-Intercept. My Y-Intercept is also an ordered pair. 0 is my X value and my Y value is wherever the graph crosses the Y-axis. That would be at +2. The vertical asymptote is the vertical line. It's kind of in the middle of this hyperbola, so if I were to draw it in right here, it's going through -1. So x equals -1. The horizontal asymptote is the horizontal line going through the middle of the hyperbola, so it's right here, going through a y value of 1. So y equals 1. And then I notice that there aren't any holes. I don't see any open points along this hyperbola, so I'm going to say none. And now it's time to write our function from this. Now, each piece of information that we found gives you information about the function. For example, if there are no holes, that means that there's no factors that are canceled out. So no common canceled factors. If the horizontal asymptote is something other than 0 or none, then that means that the ratio of the highest level, the ratio of the coefficients of the highest level terms is going to be whatever is here. So the ratio of the leading coefficients is 1. So I won't have like 2x out in front or 5x out in front. It will just be x's. The vertical asymptote helps you with your denominator. And the X-intercept helps you with your numerator. And then this is here to check. Check to make sure that if you substitute 0 for x, you do actually get 2. Sometimes you might have to change some things up, but most of the time this falls nicely into place. So we have no common canceled factors that are on the top and the bottom. The ratio of the coefficients in the front is 1. The denominator comes from x equals -1. Well, if x equals -1, then the factor would be x plus 1. Because -1 plus 1 would be 0. That's where the vertical asymptote is. And then the x-intercept is at -2. And so the numerator should be x plus 2. Because remember, when you're calculating the x-intercept, you're setting the function, or the numerator of the function, equal to 0. So x plus 2 equals 0 gives that x-intercept value of -2. And then the last thing we need to do is check and make sure that our y-intercept functions, that it works. So if 0 is your x value and you plug them in here, 0 plus 2 is 2, 0 plus 1 is 1, and 2 divided by 1 is 2. So we got it right. So in general, the function's numerator comes from the x-intercept, and the function's denominator comes comes from the vertical asymptote. So let's go down to the next question that says, what would the function be if there were a hole at -2, 0 and no x-intercept? Well, when there's a hole, what does that mean is happening in your function? That means that there are canceled factors. So the opposite of -2 would be a +2, so there would be a x plus 2 repeated on the top and the bottom of the function. So we would have f of x equals x plus 2 on top and x plus 1 on bottom, so our old function. But then we also have the canceled out factor of another x plus 2. So that's what it would look like. And this part right here is the hole. Okay. So let's move on to the second question. Let me kind of zoom this out a little bit so that we can see the whole thing. There we go. So this one looks a little strange. We don't exactly have just one vertical asymptote and one horizontal asymptote. We have multiple. So first thing I'd like to do is go ahead and write the x-intercept. So a number, 0. So I'm going to look along the x-axis, and I see an x-intercept right here. This is -5, this is 0, so we're counting by ones. -1, -2, -3. There's the x-intercept. But I also notice if I keep going, there's another one right here. So this problem has two x-intercepts. One is at -3, 0, the other one is at 2, 0. Now let's find the y-intercept. The y-intercept is the y value when x is 0. So I'm going to go look for it. This graph is awfully close to the y-axis, and I don't see any points on the y-axis, and then it gets awfully close to the y-axis down here as well. So that tells me that there's an asymptote along the y-axis. There's no y-intercept. And there's no y-intercept because there is an asymptote here, and this is a vertical asymptote going through a y value, or sorry, an x value of 0. So x equals 0 is the vertical asymptote. But I notice that there's another vertical asymptote. The graph starts curving up again like this and down again like this. So there's another one here. Kind of looks like it's going right here. So going through an x value of 5. So we have x equals 5 as a second vertical asymptote. A horizontal asymptote where the graph kind of starts to flatten out. Maybe I start from over here. It looks like it's getting real close to this line. You make sure that the other side of the graph doesn't cross. This is y equals -1. This looks good. It doesn't cross. So my horizontal asymptote is y equals -1. And then I don't see any open points here. There's no holes in any part of my graph, so I'm going to put none. There are no repeating factors, no canceled out factors. So let's go ahead and write the function. We're going to start out with f of x equals. Remember that the numerator comes from the x-intercept, and there happen to be two of them. If the x-intercept's x value is at -3, then the factor is going to be x plus 3. You need to be thinking opposites. If the other x-intercept is at an x value of +2, then the factor that goes with it is x minus 2. And then on the bottom, we need to think about the vertical asymptotes. There are two of them. One of them is at 0, so x plus 0 or x minus 0 just ends up giving you x. And then the other one comes from x equals 5. So the factor that goes with it should be x minus 5. There are no repeating factors on top and bottom that get canceled because there are no holes. There's no Y-intercept. There's no time that I can put 0 in place of x and get a number, because down here if I make x 0, then my denominator is 0, and it's undefined. The last thing that we need to check is the horizontal asymptote, and here we need to think about the ratio being -1. Well, that means that my coefficients need to simplify to be -1, and they don't. This is like a +1 out here and a +1. So I need to make something negative so that it matches up with my horizontal asymptote. All right, let's look at the last page. It says, use the graph below to sketch 3 and 4 with the given transformations. This is your graph, your starting graph, and then numbers 3 and 4 are transformed graphs from this one. So let's figure out the asymptotes and the intercepts. The intercepts are pretty easy. The X-intercept, it crosses at the origin, 0, 0. And the Y-intercept, it also crosses at the origin, 0, 0. The vertical asymptote looks like it's crossing right here. So that's at a x value of 1, 2. X equals 2. And the horizontal asymptote looks like it's going through right here. And that's a y value of 1, 2. So y equals 2. Okay, so this is kind of our basic equation. We're not going to go over what transformations do what, because at this point in the year, all the transformations look the same, and hopefully you understand how things move. For example, you might remember that anything in parentheses is a horizontal change and it's a lie, and anything outside parentheses is a vertical change, and it's changing the way that it appears to. So this piece right here, x minus 2, implies that we're shifting 2 units not to the left, but to the right. So shift right 2. And then this implies that we're shifting vertically 3 units, so up 3. Now, whenever you're doing the shifts, you want to keep your eye on the intersection of those asymptotes. So it's the intersection of the asymptotes that's moving to the right 2 and up 3. Well, that intersection originally was at the point 2, 2 up here. So that's kind of where I'm going to start it out, right here. And I'm going to shift to the right 2 and do that transformation, and then I'm going to shift up 3. 1, 2, 3. There's that new intersection of the asymptotes. So I'm going to draw the asymptotes through there. This vertical asymptote is now going through an x value of 4. And the horizontal asymptote is now going through a y value of, let's see, right there, 5. So y equals 5. And it would be a good idea to find some points on the original graph and kind of count the direction from the intersection. So like there's a point right here. It needs to be to the left 2 and down 2 of the intersection. So to the left 2 and down 2 of the intersection. Kind of looks like this. And then same thing here. There's a nice pretty point here that's to the right 2 and up 2 of the intersection. So to the right 2 and up 2 of the intersection, here's a point. And here's the rest of the hyperbola. So last problem today is one final transformation. And again, we're transforming from that top graph, so this one up here. So the original intersection was at the point 2, 2, right there. So that's where I'm going to start. And here we're not shifting any way horizontally, but we are shifting vertically. We have -3 outside, so that means that we're supposed to shift the graph down 3. So let's find out where our new vertical and horizontal asymptotes are. The intersection of the asymptotes used to be here, but if I shift it down 3, 1, 2, 3, it's now right here. So let's draw in the asymptotes, and let's draw in the hyperbola. The new vertical asymptote, still going through an x value of 2, right? 0, 1, 2. So it's still x equals 2 like the original. But the horizontal asymptote has changed, so now it's here. It's been shifted down 3. So it's going through a y value of -1. So there's the asymptote position. Remember that there were points 2 to the left and 2 down from the asymptote intersection. And there was a point 2 to the right and 2 up from the asymptote intersection. There we go. So in summary today, we were able to pick out pieces of information about graphs of rational functions and use them to create the written function using the X-Intercept for the numerator and the vertical asymptote for the denominator, fitting in all of the other pieces like repeating factors for wholes and the ratio of the coefficients for the horizontal asymptote. And then in the last page, we were able to transform rational functions through the graphs. So we were able to find their new vertical asymptote and horizontal asymptotes simply by shifting left, right, up, and down.